1.2, properties of limits. So we have started to work with limits, and we kind of understand the idea of what limits are. So now we're going to be able to combine some different properties to solve even more limits. So if you're taking a limit of something that combines two functions, whether it be adding, multiplying, or dividing, you can just break apart those limits into two or more actually, separate limits. If you have a constant being multiplied by your function, say something like 4x squared, okay, you can take that 4 out and then just figure out the limit and then multiply it by 4. Then we have the multiplication, division, like I said, exponentiation. So if your function is even that same function, limit as x approaches 2 of x squared. You can instead find the limit as x approaches 2. Okay, I can't write this out. Let's try that again. X approaches 2 of x, and then square it, and you'll get the same thing. And the last one, maybe the most difficult, is the composition of functions. So you have this composition, f of g of x. A lot of people want to take the f and just put it outside the limit of g of x. That is wrong. Do not do that. Okay, I'm going to even get rid of it so you can't even look at it that way anymore. So when we have the composition of function with limits, what you do is you take that inside function, figure out the limit. That limit becomes the new value that your x is going towards. Okay, we'll do an example and it might make it a little bit easier. And then after you practice using these, you can combine it to do something like this and get this crazy limit and figure it out. Let's try some examples. Example 1, we have some limits given, and we're going to use our properties to figure them out. All right, let's make this a little bit smaller. So we have another way to write this if you want. Remember, we could pull that constant rate out front. And again, we can combine them by subtracting the separate limits, and we can pull that constant out, g of x. All right, so now we have 2 times the limit of f of x as x approaches 3, which is 8, minus 4 times the limit of g of x as x approaches 3, which is negative 2. 16 plus 8 is 24 for our first one. Okay, the second one here. We could move the limit inside and pull that constant to the front. And then we could square the entire thing. So we have 2 times negative 2 and then squared. So negative 4 squared, we get 16. All right, this one I will rewrite it even though you don't have to. If you could start to see this, the limit as x approaches 3 of f of x over the limit as x approaches 3 of g of x plus 4 times the limit as x approaches 3 of h of x and over the limit as x approaches 3 of x plus 7. So the cube root of 8 would be 2. This would be negative 2 plus 4 times 0, which is 0 over 10. So negative 2, or 2 over negative 2 is negative 1. Sometimes you aren't given them algebraically, instead you're given them graphically. So we do the same idea. Okay, the limit, we could break this apart 2 times limit as x approaches 0 of f of x and then square it, plus 3 times the limit as x approaches 0 of g of x. Okay, look at the graph of f. As x approaches 0 from the left and the right, we are approaching 2. Okay, so 2 times 2 squared. So we get 8 for this part. Plus 3 times, look at the either side of 0 the y values are approaching 0. So 3 times 0 is 0. So then our answer is 8. Okay, this one, we're going to take -3, plug it into x squared. You get 9. Okay, g of x. Look at -3. The y values are approaching 1. Whoops. There we go. And it's going to keep changing the pages here. All right, there we go. 1. And on the bottom, -3. Look from both sides. The y values are approaching -1. So our answer here would be -9. All right, we have our composition problem. This one is one of the most difficult, even though it shouldn't have to be. Okay, we're looking at limits. We have our inside function. So what we're going to do is we're going to take x approaches -3 of the inside, f of x. Okay, as you approach -3, the x values, the y values approach -1. That becomes your new limiting value. Limit as x approaches -1 of g of x, the limit would be 1. All right, so I want you to try one like that for your whisk. Okay, put the answer, the steps, whatever you want to do in the summary portion of your whisk for part D. Okay, then we have this e value here, or letter E. So the limit as x approaches 1 from the left of f of x gives us a 2. And the limit as x approaches 1 from the left of g gives us -1. We square that, we end up with an answer of 4. In the last one, we're combining a lot of ideas. Let's start from the inside. Limit as x approaches -1 of f of x. Right there, that part doesn't exist because we have a jump at -1. So that means the whole thing does not exist. All right, so again, don't forget to put letter D in your whisk. That's enough for the properties. We'll have one more video on 1.2. Try some of your homework problems and let me know what questions you have.